times 10 to the minus 1. So you have to move the decimal over. In this case, you're moving it right, but you move the decimal over until you get that digit or that number with the first number's got to be right there.
Okay.
All right. Now, when it's negative, you put a 1 there.
Okay.
Okay. Then the next thing is you just put the number 3, 0, 1, 0. Same thing here, because the exponent is negative,
But why did you put a 0 there?
you have to fill in zeros and missing spots.
Oh, okay. Okay.
I don't know. That's those are rules. All right. And so from here you have to, because the exponent is negative, you put a 1 there, and then 0, 1 for the exponent. The exponent is 1. That's why it's 0, 1.
Okay.
Any questions on that? Do you want another one like that?
No, it's clear. That makes sense.
Okay, great. All right. Number 2. All right, determine the values of A, B, and C such that the following is a cubic spline. So the first thing you have to do is evaluate at the endpoint here. You have to evaluate. So this first one is called S1. The second one is called S2. So the first thing you do is you say, okay, what is S1 of 1? Meaning you're putting 1 in for X. So it's sorry, just looking at something. 2 plus A times 1 plus 3 halves 1 cubed. So I'm putting 1 into the top one. This becomes 2 plus A plus 3 halves, which becomes, well, we'll get to that in a minute. S2 of 1 means to put 1 in the other one. So 4 plus 5, 1 minus 1 plus B, 1 minus 1 squared, like that. 1 minus 1 is 0. 5 times 0 is 0. 1 minus 1 is 0. 0 squared is 0. 0 times B is 0. Becomes just 4. Now, for it to be a cubic spline, you have to be able to set S1 of 1 equal to S2 of 1. So you're setting 2 plus A plus 3 over 2 equal to 4. The reason it's 1, and this is important, is because 1 is that endpoint. That's why it's important. If it were, there was a homework problem where it was like -1 to 0, 0 to 1, you would do 0 then.
Okay.
Okay, but this allows you to solve for A. Okay, so you subtract 2, A plus 3 halves equals 2, subtract 3 halves, 3 over 2, A equals 1 half. That's just A. We have to find A, B, and C. Is that okay?
Okay.
Or not? There's like no calculus, nothing, that's just evaluating the function.
But
Okay, so the next thing here, I got to grab these equations one more time. All right, so the next thing is to take a derivative. All right, so you have to be able to take a derivative of the top and the bottom. So the derivative of the top one is 0 plus AX, derivative of AX is A, plus 3 halves times 3 X to the 3 minus 1 power. So this is really A plus 9 over 2 X squared. The derivative of the bottom is 0 plus 5 times 1 for X plus B 2 times X minus 1 to the power of 2 minus 1. That's your calculus. So this is 5 plus 2B times X minus 1, like that. Now we know the value of A. So we know that actually A is 1/2. So that's a good thing here. And then you again evaluate at the endpoint. So you have to actually take S prime of 1. Okay, so you're putting 1 in for X up here. So A is 1/2. X is 1 squared. S prime 2 of 1. So we're going to put 1 in the second equation. And that doesn't do any good. Darn. Okay. Why does it say C? Okay. So unfortunately, when you put that in the second equation, you get 5 plus 2b 1 minus 1. Unfortunately, the second equation is 0. But that's okay. The 1 minus 1 is 0. So you just get 5 in that second equation. First equation is 1/2 plus 9/2, which is 10/2, which is also 5. So these are the same. They're supposed to be, but that doesn't really help. Like you want to find the value of b. Unfortunately, you have to take yet another derivative.
Okay.
So I'm just bringing the equations down now. So this is S prime of X equals this. So now you have to take a second derivative. The derivative of A is 0. 0 plus 9/2 times 2x. Derivative of 5 is 0 plus 2b times 1. So this is just 9x. This is 2b. And then you again evaluate the derivative at the derivative. So you do S1 double prime of 1, which is 9 times 1. S2 double prime of 1, which is 2b. So you set these equal. And 9 equals 2b. B equals 9 divided by 2.
Ooh, this is all for one question. That's the problem. It's too long.
So my question to your thought is was the midterm like the practice midterm with different numbers?
You know, yeah, it was different. Like it had its own way. You know,
Okay.
yeah.
Well, yeah, I mean, so this may or may not be good for us to do, but that's okay.
But like
Um,
she said, if if we know how to do the homeworks and how to do this, we should be fine for the final.
well, I've heard that before. Um,
Yeah.
just trying to figure out what's going to best help you because, we don't know.
Yeah. As well, I talked to the DRC. I asked if I could have extra time over there. So
Yes.
tomorrow I'll be taking my exam over at the DRC, and they're gonna have extra time.
Okay. Well, that's good. All right. Number 3. Um, this is from your first homework. It's kind of going back and forth between topics. All right. The right square pyramid is given as, so there's just the volume formula. It's the area squared times the height divided by 3. So if you wanted a picture here, it's a square pyramid. Let's see if I can even draw it here. Something like that, where these are sides A and heights down the middle. That's your height, roughly. Okay, and they're telling you A star is 1.32 and H star is 4.5. And they want you to find the absolute error bounds of A star and H star respectively. Okay, so A star, this is kind of like question 1. It is 1.32, but in your class, you're supposed to change this to 0.132 times 10 to the minus 1. Like you have to move that decimal over. I don't know why, but that's why your class does this.
Okay.
Sort of nonsense to me, but I don't, I'm not teaching the class. So now this thing called E, I'm sorry, 10 to the 1, not -1. That's a problem. E is the exponent. And then this thing K is the number of digits. So 0.132 is 3 digits. That's where the K comes from. This E is that. All right. So your delta A star is 0.5 times 10 to the E minus K, which is 0.5 times 10 to the 1 minus 3, which is 0.5 times 10 to the minus 2. And then that's like moving the decimal 2 places. So it's 0.005. You need that number later on.
Okay.
But that's the absolute error bounds of A star. And then we have to do the same thing for H star.
So I have to put
Is that okay or not?
yeah, 1 minus.
Like these are just formulas you have to remember. Do you get a reference sheet for the exam?
What's a reference sheet? What do
Just
you mean?
something you can bring in notes or
Oh yeah. She doesn't give out, but like she allows us to get a paper with the with like we can fill it out with the formulas, but no example questions. We cannot like we can have a two-sided
well,
paper.
I would write down some of this and what you'd see here. Same with this one, derivatives and stuff like that. So we got to do the same thing for H star. H star is 4.5, but in your class, you make it 0.45 times 10 to the 1. The reason it's 1 is because you move the decimal left. So that means E is 1 and K is 2 because there's 2 digits.
Okay.
I'm sorry. That is not right. Um, sorry. K is the number of significant digits. Sorry, that's why. So for the first one, K is 3, and for the second one, K is 4. And it's the number of significant digits, significant figures.
Okay.
So
Okay.
these zeros to the right are included.
So we use the significant figures, the numbers at the question or after we change it, or is it?
I should have, K comes from the beginning.
Okay. Okay. I
Any questions on that?
know. Okay.
All right. So sorry, just let me fire this off real quick. So so this is 0.5. So delta H star is 0.5 times 10 to the E minus K, which is 0.5 times 10 to the 1 minus 4, which is 0.5 times 10 to the minus 3, which is 0.0005. It's an extra 0 in there.
Okay.
Okay, that's part A. Part B, you might recall, is what we were doing when we were doing one of the homework things, is you're taking derivatives first. So so for part B, all right, so the absolute error bound of the pyramid, to do this, you have to take a partial derivative. So your V is a squared H over 3. That's the original. And then you have to take partial derivatives. So you take a partial derivative of V with respect to A, and then you evaluate it and then multiply it by delta A star. That's why we calculated in the first one. Then you take a partial derivative of V with respect to H and delta H star. So we're gonna do this in pieces. We have to take a partial derivative of V with respect to A. So you're treating A like it's the variable.
So
It's just power. But
that's the formula.
this is the original problem. This just is the derivative. The derivative times the error.
Decrement, I should write this down for tomorrow. I could use that or.
I mean, she's gonna give you a different equation, so you have to know how
Ah,
to take a derivative. This stuff you should write down, the whole like, K is the number of significant figures, and E is the exponent of the thing that you're,
okay.
that for sure.
Okay. Okay.
Okay, so we have to be able to take a derivative, and that's where I'm really worried for you. I just, I know that's not a strength of yours, but the derivative with respect to A, the derivative of A squared is 2A. So this is 2A H over 3, but then you have to evaluate it at A equals A star and H equals H star. So you have to put those values from the problem, from the original problem. So it's like this: 2 times 1.32 times 4.5 over 3, absolute value of that, times 0.005. The 0.005 is the delta A star,
Okay.
plus. Now you have to take a derivative of this with respect to H. So the derivative with respect to H is just 1, so it's A squared over 3, but again, you have to evaluate it at H star, H equals H star. So in this problem, it's just 1.32 squared over 3 times 0.0005. And then you just put this in your calculator. There's no more work to do. In fact, your teacher doesn't even evaluate this. They just leave it like this.
Yeah.
Okay. Number 4, 3. Yeah, okay. All right. So, we want to do this. Determine the coefficients A and B that makes the formula integral from 1 to 2 f of x dx equals A f of 1 plus B f of 2, exact for all polynomials of degree 1 or less. So you have that's key right there, is degree 1 or less. That's AX plus B, like that. All right. So when you integrate AX plus B dx from 1 to 2, you have to know how to find the antiderivative of this. So just to be clear here, your f of x is AX plus B. So f of 1 means A times 1 plus B.
Oh, is it always ax plus b or
For degree 1, yes. For degree 2, it's AX squared plus BX plus C.
okay?
And so that's just A plus B. But then there's this A out in front. I don't know why she's doing that, but so A f of 1 is A times A plus B. And then f of 2 is A times 2 plus B, 2A plus B. B times f of 2 is B times 2A plus B. Now, what bothers me is these were coefficients in, like, in your homework. This was like 2/5 and this was like 3/5. And so I'm wondering if you're supposed to use different coefficients. I guess we'll find out here in a minute. So find out. All right, so on the left here, this is A x squared over 2. plus bx, and you have to evaluate from 1 to 2. All right, so when you evaluate, it's top minus bottom.
Okay.
So you're putting that 2 in the top. So it's a 2 squared over 2 plus b times 2 minus a times 1 squared over 2 plus b times 1. So 2 squared over 2 is 2a plus 2b minus a over 2 minus b. So this becomes 2a minus a over 2, or 1/2 a, is 3 over 2a plus 1b. And that's supposed to equal, that's where this is a little bit weird, is that's supposed to equal af of 1, a times a plus b, b times 2a plus b. Let me check the solution. Sorry, I should have done that from the beginning.
Solution. She got A half and the B half.
Yeah, I see that. And she's not doing it all this complicated stuff. So what am I missing here? F of a plus f of b divided by 2 times b minus a. Yeah. I don't know. That doesn't seem right, but okay. B minus a. This must be a shortcut
Okay.
for degree 1. So I would just write all this down.
The
The
solution.
stuff I'm showing you is from the homework, but that's clearly not what they want.
Okay.
A is 1, B is 2. 2 minus 1.
Solution that she wrote, is that the formula I can use, or is it?
I mean, it might work for degree 1.
Okay, okay.
The one I'm giving you is the more general form. Like I said, usually A and B are these numbers, and you prove whether it works or not by doing this integration and then this stuff. So we were about to get something like that. And let me see here. I mean, we should get the same answer. A times A plus B plus B times 2A plus B. That's 3. So if A is 1/2. Huh. Okay. I don't know. Let's just keep going.
Mhm.
Oh boy. All right. Number 5. 5 is a monster. Okay. So here's number 5. So I guess to answer your question, I would write down the solution that she put in the practice for number 4, but I don't think you'll get that, but you could try. You could just writing something down would be good.
Okay.
All right, now in the quadratic interpolations, you have to first make a table of x and f. And I did look at the solution before going on it. So x is 0, y is 2, x is 1, y is 4, x is 2, y is 12. And so
X,
what you have to remember,
F, do you mean with
f means y in this problem.
X is
X is 0, this is x, and this is f. X and f, x and f, like that.
okay.
All right, now you have to know this formula for the quadratic interpolation, which is F1 L1 plus F2 L2 plus F3 L3. That's the only way that's for a quadratic. That's probably what you'll get.
Okay.
is you have to know this formula, and that's in the solution there. You have to know that formula, and then you have to know the formula for each of the L's. So there's three formulas. There's one for L1. So we'll start with L1. So the formula for L1 is X minus X2 minus X3. So this first one is X1, X2, X3, like that. This is F1, F2, F3. So notice to find L1 on the top, you use the ones you don't have. So it's X minus 1, X minus 2 over X1 minus X2, 2 minus 4, X1 minus X3, 2 minus 12. Sorry, I got these wrong. Apologize. 0, sorry, 0 minus 1, 0 minus 2. So notice that the numbers in the top and the bottom are the same.
Yeah.
Is that okay?
I can write down the L1 F.
You have to have that formula. Yes, there's no way to do this without. Everything else is just putting uh, the numbers in. So this ends up being 1/2 X minus 1, X minus 2. And actually your teacher doesn't even simplify this. So you just need the formula. So let me grab the formula for L2. That was one of the things that was unclear about the homework, is like how far you need to simplify some of these things, because they're kind of awful. So this is, you're going back to the table, X minus X1. So it's X minus 0, X minus 2, and then X2 minus X1. So that's 1 minus 0, 1 minus 2, like that. So this one's negative 1/2 X times X minus 2. And then similarly, there's a formula for L3. This one is X minus 0, X minus 1, 2 minus 0, 2 minus 1. So that's, again, 1/2 X, X minus 1, right? So you need these three L's, L1, L2, L3, and then you use this formula. Somehow her handwriting is better than mine. So use this formula. Your F1 comes from the table. Your F1 comes from the table. It's the first value. That's the 2.
Okay.
So it's 2 times the L1 that you just found, which is this stuff right here. Plus F2, which is 4 times L2. And apparently you just leave it. Like in the homework, I wasn't sure. You just keep doing it. 12 times, that's F3 times L3. It's not too bad if you have the formulas.
Okay.
Any questions on that?
I'm just writing down the formula. Cool. Okay. Okay.
The next problem is Newton's method. Good old Newton, Isaac Newton. More famous now that he's dead. All right. If the Newton method is applied to the root of f of x, and if x of n minus 1 equals 1, what is xn? Okay, so there's a formula that you have to know, which is xn equals xn minus 1 minus f of xn minus 1 over f prime xn minus 1. Your teacher, I guess her handwriting's a little better. Remember that. So you just need a couple of things here. It's not really that bad. So in your problem here, and kind of a better way to look at it is x2 equals x1 minus f of x1 over f prime of x1. Okay, and so if you think of this number as x1 that they're giving you, to find the next value x2, that's what xn is. It's just literally the next value. You just need a couple of things. You need the actual value. You have to evaluate the actual value, and then take the derivative and evaluate the actual value.
Okay.
So it looks more complicated than it actually is. I mean, you need to find f of 1. 1 to the 4th plus 2, 1 cubed minus 3 times 1 minus 5, which ends up being -5. It's nice. You have to be able to take a derivative. Your derivative is 4x cubed plus 6x squared minus 3. And then you also want to evaluate f prime of 1 is 4 times 1 cubed plus 6 times 1 squared minus 3. And that is 7. 7. So once you have those numbers, the first number goes in the numerator, second number goes in the denominator. Your x1 is what's given. So the answer here is it's 1 minus -5 over 7, which is 12 over 7.
Okay. Okay.
You have time to ask your teacher a question before the exam?
I consider an email.
Okay, the reason I ask is because your instructor uses Gaussian elimination in this problem.
Okay.
And before you do Gaussian elimination, you're supposed to take what's called the determinant of A. And if the determinant of A does not equal 0, then it's got an inverse. Your teacher goes to the trouble of doing the Gaussian elimination, which is fine, but you should do the determinant of A first. So if you take the determinant of this matrix, you'll find that it's 0. So there is no inverse. But the teacher doesn't actually do that. They just sort of mention it off to the side. Like they're like, oh yeah, if it's 0, you know. But so I guess what I'm saying is, like, they went to a lot of trouble here, even though you're supposed to check this first.
So this question should not be answered. Just
Well, I don't know. The email would say, um, can I take the determinant of A before using Gaussian elimination to determine if it has an inverse? Because, like, you would find the determinant is 0 and you would say it does not have an inverse, which is the same answer they get.
okay. Or or maybe she wants us to work out why it's a 0.
No, I mean, I'm trying to say like, you would never do this. You would just, how do I say this? Like the teacher does the Gaussian elimination, but you don't need to if you figure out that the determinant A is 0.
Okay.
So I don't know, you can decide. Now, in terms of how you actually do it, you write out the numbers in the matrix. And then you create the identity matrix on the right here. I think you remember doing this in one of our earlier lessons, is you do some row operations, right? So you take row. So your teacher does this really fast, which I mean, it's great, but it's not very helpful for you. Your teacher says to take row 1 divided by 2, negate it, and then add it to row 2, and this becomes your new row 2.
So 1 minus.
So take everything in row 1 divided by 2, then negate it, then add it to row 2. So here's the result of that.
Oh, so I can get a 0.
Well, yeah, you want a 0 in the first position. So you end up getting 0, -7/2, 4, -1/2, 1, and 0. Then you do the similar. You take row 1, multiply it by -2, add it to row 3, and this becomes your new row 3. So you take everything in row 1, multiply it by -2, and then add it to row 3. So the result is that you get 0, -7, 8, -2, 0, and 1.
Mm.
Right. So yeah, you want to get zeros here on the left. Then you take row 2, multiply it by -2, and add it to row 3. That becomes your new row 3. So what that does, and that's where the problem is, you end up getting, I'm going to rewrite. You end up getting 0, 0, 0, -1, -2, 1. And this is a problem. This is
Okay.
bad. That means there's no inverse.
Okay. Okay. Makes sense.
Are you okay?
Yeah.
Right. All right. So 8A is called a tracing exercise. You're tracing the code. All right. So imagine your computer. So the first thing you see here is you say, okay, X is 1. Okay. So in terms of how you do this, X is 1. And then you enter this while loop and you say, is X, which is 1, is that less than or equal to 10? Okay. And the answer is
Yes.
yes. Yeah. So you're good. So you're going to do this.
Okay.
So what are you going to do? You're going to take A and you're going to add it to what's called the I matrix or identity matrix of 2 by 2. What this line means is you're taking 1, 2, 3, 4, and you're adding it to 1, 0, 0, 1. All right. And then it's becoming a new A. That's fine. Then you take X and multiply it by 3. So X is no longer 1. It's 3. So your while loop has been done one time. Then you come back up. So in here, you're kind of looping back up. Your new X value is 3 less than or equal to 10. Yes. So you're going to execute this stuff again. So you do this matrix manipulation, whatever, but then, and you don't even need to know this. You need to just look at this. Then you're taking your X value and multiplying it by 3. So your X value is now 9. Is 9 less than or equal to 10? Yes. So you're going to execute the while loop a third time. But this time, when you multiply by 3, it's 27. And now you're going to stop.
Okay. That's why it's 3, because you stop at.
Yes. Yes.
Okay. 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 Makes sense.
Okay. Now to do part B,
Mm.
which is a little more work. Okay, what does the resulting matrix say? So that's what I was trying to show you here. Okay, if you look at the code again, we'll look at, let me snip the code in. Okay, so you're in the while loop. You're in the while loop. You don't care about your X value. A is currently 1, 2, 3, 4. But now your new A is 1, 2, 3, 4 plus 1, 0, 0, 1. So you have to actually add these together, and that's 2, 2, 3, 5. So that's your new A. That's part B.
You added them. Three.
Yeah, the I2, this is I2 over here.
Okay.
It's an identity matrix of size 2 by 2.
Okay.
All right. Now, part C is, well, what happens if you keep running the code? So how many times does the loop run? 3 times. We ran it 3 times. So you have to do this 3 times. So the first time you run, the first iteration A1 is this 2, 3, 2, 5. The second time you run it, it's 2, 3, 2, 5 plus that identity matrix again, 1, 0, 0, 1, which is 3, 2, 3, 6. Then you run it one more time. The third time you run the loop. You take that matrix you just got 3, 2, 3, 6, and you can add 1, 0, 0, 1, which gives you 4, 2, 3, 7.
Okay. Okay.
And I guess your teacher does show that. I didn't see that, but yeah. Okay. That's everything.
Right.
So, I mean, the good news is if the test was like this, you could do it in 46 minutes. Theoretically.
So,
So, anything else you want to cover today?
no, that's it.